Hello, welcome to my YouTube channel. My name is Boniface Emmanuel. I am a student at the University of Nigeria studying computer science and second year undergrad. I am currently interning with Spark Foundation, and today we'll be looking at the first task which I did at Spark Foundation as an intern as a data science and business analytics intern, which is the student score prediction. So that is what we'll be looking at. So yeah, so this is a regression task or will predict the percentage of students, or yeah, the percentage of students is expected to score based on the numbers of hours they studied. So this is a simple linear regression task that involves two variables. Definitely at the end of this project we'll be able to predict scores of students based on the numbers of hours they read or they studied. So we get right in. First of all, we have to start by importing the libraries. As you can see here, we imported the libraries. We imported pandas, numpy, matplotlib. Yeah, so these are the three libraries we imported so that we can be able to, um, perform some numerical, statistical, and you know data visualization functions. So the next step is to read our data from the remote link given to us. So in the project we were given a link, and this is the link here. So I have to read the the link. I have to read the data in the link provided for me using the link, and I imported the data. Then I have to import all the whole data. So I have to write here dot head. Let me rerun this code here, then come here. I have to write dot head so that you can see the first 5 lines of the code that is under that is provided for with the remote link. Then after that, we're going to plot the distribution of scores. That's making use of matplotlib. We have to visualize how it looks like, making use of scores versus data. So we look at, from what we can see here, that the more they read, the higher they scored, something like that. So that's from the data. So next off, we need to prepare the data. So in preparing the data, we actually divide the data into attributes and labels. So labels is what we'll be predicting, while attributes are actually the numbers of hours studied. So we are going to be just, predicting the score itself. So I had to divide the data into different values, the different yeah, I had to divide the data into attribute and label. So this is the I think X here is the label, is the attribute, Y is the label. So after that, I have to split it into training and what are you calling it, training and testing data. So first of all, I have to train the data, that is the data given to me after training first of all. So after training the data, and then I will then test it using my test data. So I imported from scikit-learn model selection. I had to import train test split to train the data. I split the data into testing and training data. And if you can look here, if you look at this parameter here, the test size here is what, 0.2. Definitely the training data will be 80%, as far as the test data is 20%. So next up is Training the algorithm. So in training the algorithm, we are going to import yeah, we're importing from scikit-learn the linear model, and we are going to be importing linear regression model. So this is the model we'll be using to train our data. We feed the data into they feed the training and test data, and we actually have to train the data using that model. So after using that linear regression model, so after training the data, using linear regression model, know that, let me just explain what linear regression model does. It predicts a discrete value. It is a supervised um, it is a supervised machine learning. Yeah, it's a supervised machine learning model. Under supervised machine learning, we have classification and regression. So regression, we use it to predict a discrete value, while for classification, we use to predict uh, one or two input or output, something like that. Maybe to this for classification, we talk about uh, let's say differentiating between cat and dog, something like that. But for this one, we have to predict just a certain value itself. So we have to draw a line, a regression line, plot a regression line, which actually gives us a scope. That regression line you see here give us a scope, so that whenever we are predicting, let's say that the person reads for 3 hours. So when it goes up straight to the line, we need to predict, okay, the person will be scoring less than 40, something like that. So this regression line then actually helps us to predict, tell us where or what we are actually predicting, or the score we will be from the numbers of hours read, the person read from the data set given to us. We'll be able to predict the numbers of hours, or the number, or the score the person will have, something like that. So this is it here. Let me rerun it again. And then next off is, after doing that, we have to make prediction. So in making prediction, we make prediction making use of our testing data, and our testing data in R, we have to print it out to see what it is. So this is it here. These are testing data in R, 1.5 R, 3.2 for 7.5. So this is in an array. So the numpy take care of this for us. So this numpy is what take care of this for us. So we have to predict making use of the testing data. So we have to compare actually the actual versus predicted. So actually from our training distance data, from our training data, or from the training data, what we discovered is that the actual score was 20, and it predicted what I calling it, that is, it's predicted, this is what we are predicting actually, this is what we are predicting actually, the score. So making use of the test data, like the real actual score for the y test is the actual score itself. That what y test is. This is what we find here, the actual score for the testing data, but it predicted 16.88, which is very close. Then for 27, which is the actual score, it predicted 33, because why it's predicting this is predicting it based on that model itself. So that is how they are, like 69 is predicting 75. It's still on the same range. It's kind of over 15. I don't know, it's not over 15, sure. Well, 62, 60, yeah, kind of within the same range. So it's actually predicted it well. So we were asked in the in the video, or in the task, to predict what if the student scores 9.25. What would be the score of that student if the student read for 9.25 hours? And as we can see here, when we run it, you see that it's predicted it for its predicted score is 93.69%. That is, the students will score 93.69%. Okay, let me Oops, okay, let me reload it. Kind of probably just ran out of space. So okay, it's reloading. Now this is Google Collaboratory. So this is it's an online notebook we use in writing, uh, working with our machine learning. Because see, if the student reads for 9 hours, let's see what is going to score. I just want to just make it much more flexible so you understand. So look at it here. So the student was scored 91.21. So this is 0.25. Let me continue to 5. You see that I told you from the other visual. So what we visualized before, we do is that the score increases, the numbers of hours increases, the score increases. That's what we got. So from here we discovered that as he read more, he scored more. 9.25 hours, he scored 93. So evaluating our model, we are going to evaluate our model, the performance of our algorithm using the mean square error. So to do that, we have to import scikit-learn, import metric from scikit-learn to actually calculate the mean absolute error. So which is 4.1, which is very close to 4, which is a very good metric or a very good performance of the model. So we have come to the end of the video. If you like this video, I would like you to like the video. If you like the video, if you enjoyed it, just like it, like the video. And if you are joining us for the first time, please try to subscribe to this YouTube channel. And also tell me if you think you want to add more, you want to see something more about the project, please write it down in the comment section below. And see you in the next video. Thank you very much for watching.